experience in software development and architecture, as well as expertise in machine learning, deep learning, and natural language processing. He has 4 years of research experience in leading NLP tasks. Santipriya sir has more than 60 publications and over 340 citations. He is a part of the program committee for many top-tier NLP conferences and workshops, currently working on finalizing his book in collaboration with other NLP researchers, Natural Language Processing in Healthcare, a special focus on low research language. He has a significant research contribution towards building language researchers for ODIAs. So some of this include ODIA to English machine translation corpus, language model for ODIA, ODIA tree bank, Santali tree bank, Santali dialect detection dataset, ODIA NLP research catalog. So I would like to welcome Dr. Santi Priya sir. So hand over the session to sir. Please sir, you can proceed now.
Yeah, thank you, Manisa, for the welcome. And yeah, so welcome you all in the third day, second session. So let's begin. Let me share my screen quickly. So hope my screen is visible.
Yes.
Okay. Yeah. Thank you, Santanu. And okay, so let's begin. So this is the title of the talk: natural language processing and application. So I'll go through the agenda. So agenda mostly it's like I'll try to cover many NLP applications and give you some introduction to what is natural language processing. So we'll start from the language. That's when we say natural language processing. So the language and resource, and also we'll start some of the NLP applications, few of the NLP applications, because natural language processing is a very broad area. So I'll try to cover a few of the NLP applications with some of the case studies which we have done. So this is the broad agenda. So, and at the end, I'll discuss about little bit about the mini project which we are conducting in the summer school. Yeah, so let's start. So before starting, yeah, I'll give. I want to give you some of the facts. I think most of the time I am trying to start my session with some of the facts about. This is actually mostly the facts about the languages. So maybe you guys can you can see and you can find out how many of these facts you have been known. So okay, so these are the facts about the languages. So if you know, like I don't know how many facts you know, but in world means around there will be around 7,000 languages. Languages are there, and you can see a lot of facts about these languages. But some of which is really we are interested in, or which really focus our attention. So if you look into, already I have highlighted. So here, if you see around 2,400 of the world's languages are currently in danger of becoming extinct. That what does it mean? That means like when we say, sometimes we say language is died or language is dying. So what does it mean? Or it is extinct. So, and why? Those we'll try to discuss that little bit. And also we'll see that, okay, about one language becomes I have highlighted here about one language become extinct every 2 weeks. Like so many languages are there, and like languages are also dying. So languages is not only for it's not only used for only communication purpose. It carry a lot of things. Like when we are talking about okay, we say that okay, Odia or Odisha or our language is Odia. So it meant a lot for the same for any of the community. So it has a lot more meaning rather other than the communication. So, and some more facts you have also you have been known, or you can see that okay, languages in Europe they have, like you can see that like languages in America or languages in Asia. So you can find out that there are many interesting facts about languages. So I'm not going to read one by one, but you can, yeah, you can go through it, and I have given the source link, so where you can find the uh, fact about the languages. So, and also in the same way, if you come to um, India, now we are coming about India. Okay, we'll see that okay, we have so many languages. We know only few because, but other than that, actually, we have a lot of languages. So, okay, some of my question is like how many facts from the above slides already you knew, or if you have some interesting facts about languages or in Indian languages, you can share it. So for example, okay, some of the in a few years back, there was a news like upset coast of India, another language dies. So if you know that, okay, there was one lady, so she is the only lady who knew that particular language, and when she died, that language gone. Means nobody's know because there was no document or no digitization, and yeah, so now nobody knows about this language. So this is not only one, like several of such languages are there where uh, people say no, but uh, and once they die, that language has gone. So what you can do, like how to preserve those languages. So now many researchers are working in this particular direction, like they are trying to digitize the content or creating the resources for that particular languages. So those we can see, and if you have any interesting facts, you can also share it, or you can in chat you can type it. So which at the end maybe you can see or discuss. So that will be uh, uh, some of the motivation, like or that will be, I can say some of the introduction about the languages, and because when we start from natural language processing, obviously it will be start with the language, and then okay, then we'll see that okay, how it will be computationally, how we can communicate or how we can start computation. Uh, so I'll I'll start with that. And already this is the map. As I have seen, there will be around 7,000 languages in the world. So I don't know how many languages is. It is very difficult to know all the languages, but even in India, I think people have known only few languages, maybe 22 or 23 languages. But apart from that, also there are so many languages in India as well. And in the over the world, there are so many languages that exist. But what about those languages? Is all languages are there, or where the resources are there? So if we, for example, if we talk about one of the uh, uh, one of the place where we store the informations mostly, like Wikipedia. So now if you look into Wikipedia, it's keep on growing, but it has text like around 13 languages. And even if you try to find out Odia language, like recently the Wikipedia has added many content in Odia wiki, and still volunteers are trying to add more and more content into wiki. And this is still it will be around maybe around 300 languages are there, 330 languages are there. So in world, in the previous slide already you have seen there are around 7,000 languages, and the contents are like in 313 languages already there. So what about the other languages? Is are the contents are there, or we're trying to build the contents, or so those things are research questions where people are trying to answer. And when we talk about natural languages, okay, this natural language technology development depends on mostly large number of language resources like text or speech. So if the resources are not there, then how we can build the technology? So so that is the lack of language resources affect the development of natural language technology. So whenever we say that technology, one of the input will be the data. So if the data will be not there, then how the technology can work? So for example, like already we have seen how many days it took for like ODI language to come into Google, because there was no data set was available, no resources were available, and it took a lot of long time, and still it is not very accurate. So similarly, we have this is a ODI, but in Odisha also we have so many languages in different dialects are there, different languages are there. So so where those resources, or if we try to build some technology for those languages, so first thing is that we have to consider about the data and how to build the resources, then only we can try to build the technology. And without data, I think there will be no technology, although there will be, now people are trying to find out different ways, which we'll discuss in the subsequent slides, like okay, how we can utilize some of the information from other languages, or the languages which have resources, to utilize those for some other or unknown languages, or some languages which doesn't have the data. So that we'll see. And now talking about the resource, so yeah, so this will be maybe some of the resource we are also interested, or one of our research focus is like to try to build the resource in different languages. And these are the list of resources which already we have built over the over last few years. I can say last I think 2 to 3 years we built. So these are like we like ODN Corp 2, it's a English to ODI machine translation corpus, and ODI tree bank, and Hindi visual genome, it's a English to Hindi multimodal dataset, Malayalam visual genomes, and yeah, and yesterday we released these two Bengali visual genomes, also a English to Bengali multimodal dataset, and also Hosa. Hosa also, it's a African language which we have yesterday we released. We have a paper in LREC, so about Hosa, and also like English to Hindi machine translation systems. And okay, so for talking about build a NLP resource catalog. So I don't know if somebody has already. I have given in the website also the link. So where we are trying to put all the links of all the resources. So it will look like this. So you can find out all the resources which can be used for NLP. So that we are trying to find out, like corpus, or it will be different kind of models. So all the libraries or tools. So that link is there, so anybody can go through it. And also I want to highlight that okay, you can utilize that. So next, when we talks about this natural language processing, so mostly what about natural language processing? So it will mostly we are trying to it helps to communicate with the computers. So it will be like just as we are communicating with each other, we are trying to communicate with the computers. So so it will help computer to communicate with the humans in their own language, and scales other language related tasks. So like so if you talk about nowadays, I think it is quite common, like you can communicate with your own language to computer. Like for example, if you talk about Alexa, so now those technology has evolved so much, like when we are trying to communicate, okay, you can also communicate with your own language. But what it involves, like how we can communicate. For example, okay, when we are talking about a person to person in a natural language, and we are trying to communicate with the human to computer, so what's the difference? So that is, I think, uh, quite the research topics, and lot of research has been done, and still we are trying to improve. For example, we are talking about, okay, let it be speech for Alexa. So is it able to understand all kind of communications, or sometimes we are trying. So for example, like we are trying to translate it. So whether we are able to translate it into 100% with accuracy. So there are a lot of research improvement are there, which we are focusing or we are trying to do over the period of time. So this NLP, it will makes you possible for computer to read your text, the speech, you can interpret it, or you can measure the sentiment. So many things you can do with NLP. So which we'll discuss in subsequently. And now recently, actually, I want to just introduce this slide about this deep learning, because now already we have seen in previous sessions about machine learning techniques and how it is used. And in deep learning, actually now this has really improved for the performance for many of these technologies. And also in NLP, also after this deep learning, the performance have been really improved. And so what is deep learning? So okay, so now you know the machine learning. So here I have given one simple image where you can see that, okay, there will be an input of a car. Okay, there will be person is there who is trying to extract some features. Then those features it will try to put into for classifications. Then it will, okay, we are trying to classify into two sets, like whether it is a car or it is not a car. So there are a lot of steps are involved. And when we are talking about deep learning, okay, there will be input and okay, there will be output. And okay, so it includes this feature extraction or classification, or sometimes we call it like a okay black box, like okay, we doesn't know what is happening inside deep learning. So you will just input and you will get your output. So that is a really a challenging field of interest. Like people are trying to understand, okay, what these models are really learning. So how they are classified. So that will be in a overall view. Okay, you can see that, okay, it will be like a we can call a magic black box. Okay, where it can perform very well. But at the same time, you need to also understand many things like so this is we can call it like a machine learning software learning representation of the data, and it will be exceptionally effective for learning the patterns. And also this deep learning algorithms, they try to attempt on multiple levels of representation by using hierarchy of multiple layers. So if you try to implement this deep learning, so you will find that there will be a lot of your this number of hidden layers. It will be more, and number of it will be a complex architecture, mostly I can say, or in a simple form it is a complex architecture by the simple neural network. And also some people also call it like, okay, it is just a, you can just addition of layers and it will be complex and it will become a deep learning or a deep learning architecture. So but one thing it is very or it is true is like that, okay, if you provide the systems with tons of information, it learns to respond in useful ways. So what does it mean? So like based on your problem. So if you want to, for example, you want this deep learning will really works if you have lot of data. So and if you have a number of data or the size of data set is very small, then there is no need of going deep learning. And even if you try to use deep learning, you won't get very good result. And also same thing also we have already noticed in many of these occasions. For example, like in machine translation, assume okay, you want to translate from one source language to another target language. So if you have millions of records or millions of sentences, okay, parallel sentences, okay, you can go for deep learning methods and it will give you very good result. But if you have some very few sentences, maybe assume you have only few thousand, 5,000 or 10,000 will be there, then deep learning, it is not suitable for you, because you can go for some statistical approach and that will give you better result compared to deep learning. So that based on your problem or the domain and the available data set, you have to choose. So that is actually one of the, in a simple way, I can try to explain. But next we'll see some of the applications. Why I have explained the slides, because the reason is like although I am trying to put the presentation very simple, but also in many places we are also using this deep learning applications or methods. So it will be easy for explanation. So in NLP, it will be in everyday's life. So I think everybody is using NLP without knowing the technology behind it. For example, like personal assistant, this Siri or Cortana or Google Assistants, or we are trying to autocomplete search engine. For example, like when we are suppose, okay, this one I was trying. Okay, if we try Odisha, then it will suggest you, okay, Odisha Machine Learning Summer School, Odisha Corporate Foundation, Odisha Summer School, Odisha Transport, like this. So how does these things happen? Or for example, you want to translate something. I have given, okay, Odisha Machine Learning Summer School. Okay, you want to translate from English to Odia. It is coming Odisha Machine Grishma Vidyalaya Sikhuchi. So when in the previous few minutes back, I was telling that because still we are not reached to that particular level, because and we need lot of research. And still the research is going on about accurate translation, and that is the challenge in NLP. Because you also agree with me that, okay, this translation is not completely correct. Uh, Odisha missing Grishma Vidyalaya Sikhuchi, or if you ask some human, he can interpret in a more meaningful way. So, and maybe if you want, you can translate it for Odia, no problem. And like a chatbot, we are so most of the times you can if you go for any product or any company sites and you try to communicate with the customer care executive, okay, you can encounter some of the chatbots. So like every day we are using NLP, and now we'll see, like, okay, we'll try to learn some of the NLP tools and technology, and how does it work. So why NLP is difficult? So okay, we know that, okay, so these are the applications of NLP, and still some challenges is there, or still things are not very correct. But why NLP is so difficult? Because the natural language is very highly ambiguous, because there are many factors are there. For example, okay, I have given some example here. Words can have several meaning, and contextual information is necessary to correctly interpret the sentences. Because as a human being, okay, we can easily identify it, but how it react when the machines, because they don't, because they know they doesn't know the context. So for example, okay, I'm giving a simple example here. So okay, there is, we are saying that, okay, the left figure, we said that, okay, this will be a street sign advising penalty, and the second, the penalty box is a white line. Now the same word penalty is a appear in both those sentences. Now you try to translate without the image information. You just try to translate it using any translation. So the translation, how it know? Okay, you are talking about which penalty, or what is the meaning of exactly penalty? Because here, okay, you are talking about street sign advising penalty, means you are trying to make about penalty means fine. Like if someone is violating traffic, so he has to give some fine. And here we are talking about the penalty box is white line, so we are talking about mainly a penalty kick. So how, so for example, maybe as a human being, you are intelligent enough and you can translate it correctly, but how, what about the machines? Because he doesn't know the in which context you are telling. So I have just given a simple example. So there are a lot of ambiguities are there, and that's why it will be really difficult in this NLP task. And the syntactic analysis, syntax and semantic analysis, the semantic are the two primary techniques that lead to understand of natural language processing. So this is already, we know, okay, mostly there are different techniques are there to identify this kind of text. Okay, we can go for some kind of parsing or this syntactic analysis, like every language follow some of the grammar, like whether it will be subject verb object or subject object verb. So there will be different patterns. We know that what will be the structure. Also the semantic, the meaning also it will be there. So there are different techniques are there in natural language to understand it, but how we can interpret those to the systems or to the computer. So that is the challenging task. So then only we can say that, okay, now, for example, in this case, the context, how we can implement this context so that machine also can understand. So like nowadays we are learning about language model or transformer part where we are taking about the context. So those things, okay, how we can implement it. Into next. So we'll see some of the uh, NLP applications. I'll start with some of the NLP applications, like where we are using. So like we are using like a text classification. So for example, like in text classification task. So where you have mostly you have some text and you want to classify the text based on some category. So like for example, like you have a set of documents are there or news is there. Now all those news you want to categorize the news, whether the news about politics or news about some sports. Uh, so that is your task. So mostly here you have text and you want to classify. So in the traditional, okay, we have different techniques are there, mostly where you need the label data. For example, like in machine learning, you want to build some model. So as you know that mostly in machine learning, you will have two kind of techniques available. Like one is like you have some unsupervised approach or a supervised approach. So in unsupervised approach, okay, you did not uh, require the label data, and in supervised approach, okay, you need a label. For example, talk about this text classifications, and you have text as well as label data. Like label will be some text. First, you need to label it as okay, this is the text is about politics. This text is about literature. This text about sports. And once you have the label data and you build the models, then you during the inference, if you provide some input, it will tell you, okay, this will be go to the this will be the politics, or this will be sports, so like this. But nowadays, okay, this is in the traditional way. Now in we are talking about, okay, as I have mentioned that, okay, in deep learning the performance has gone quite a lot, and we are talking about mostly you have been seen like a zero shot learning. So what does it mean, like in zero set learning? So uh, I have the link here. So if anybody want, they can also try it. So here, so in zero set learning, okay, mostly now we are saying that, okay, without using any or without any label data, also it can classify. So or it can do some kind of text classification. So I don't know how people will say, maybe uh, you can see some for, okay, for the demonstration, okay, I tried some examples. So mostly why we call zero shot, because you need not any label data, absolutely zero data, and you can also get the classification. So you can say, okay, zero shot text classification technique, it will classify the text document without using any single label data or without having seen any label data. So for example, okay, you can also try. So okay, I have tried in both the language, English and Odia. So now because we have very good language models are available, and it supports many languages. I think this one is support around 100 languages. So here actually I have input. So you need not to do anything. So you have to just provide the text, and you have to provide some category. For example, okay, my text is I have put it here from, I have taken from this AIML Summer School website. Like we aim to provide the next generation participant with best in class training on a broad range of advanced topic and development in artificial intelligence and machine learning, including deep learning. And some of the categories I have given, like skill development or entertainment or travel or education. And I selected, okay, allow multiple correct topics, and you can see the prediction. I didn't train anything, so I just the text and the categories, and it said that, okay, it will be about skill development with a probability of around 84 point, around 85%. It will be of skill development, or education is 66%. So you can say like whether it is a good or bad classification. So similarly, assume okay, I have tried to uh, provide some ODI data. So and I didn't train any model or anything. So I just provide the same ODI data with a which you say okay, I'll read. ଆମେ ପରବର୍ତ୍ତୀ ପିଢ଼ିର ଅଂଶଗ୍ରହଣକାରୀ ମାନଙ୍କୁ ଉନ୍ନତ ବିଷୟ ଏବଂ କୃତ୍ରିମ ବୁଦ୍ଧିମତ୍ତାର ବିକାଶ ଏବଂ ଗଭୀର ଶିକ୍ଷା ସହିତ ମେସିନ୍ ଲର୍ଣ୍ଣିଂର ବ୍ୟାପକ ବିସ୍ତାର ଉପରେ ଶ୍ରେଷ୍ଠ ଶ୍ରେଣୀ ତାଲିମ ପ୍ରଦାନ କରିବାକୁ ଲକ୍ଷ୍ୟ ରଖିଛୁ. I just use in Google Translate this translation, and my possible category I have given like dakhyata vikas, manoranjan, brahman, shiksha. So now you can see that okay, it will try to classify this as 98% it will be like shiksha or dakhyata vikas, of brahmana will be like 51%, or manoranjan is 36%. So you can see like that okay, how good or bad it is, the text classification. So these are like where the deep learning comes into pictures, and mostly it will be based on, because now we have very good language models are there, and using which we can do very great performance, I can say. So so this is one of the application in text classification, and we are talking about the language model, because language model every most of the, so nowadays it is quite popular. We are talking about BERT or Robota or with the GPT. So we'll discuss that also. Also another application like in NLP we do mostly in the named entity recognition. So named entity recognition means now you have a text. Now from the text you try to find out the entities. So all the possible all the interested entities. So here it's a so for example here my entities of interest is like organization, quantities, or people's names, company names, geographical location. So now you just have a text and it will give you all the entities. So okay, I have input the same text from the same what is ML Summer School website I have taken, and it will tell me that okay, what are the entities present in the right hand side. Like okay, it will identify okay, Odisha as a GP. GP means geopolitical entities, which will be like countries, cities, states. So Odisha is a GP. June July 2022 date. 100 is cardinal. IML summer school organization. 5 days date. So you can see, I can in the named entity. Okay, now from the text you can find out the entities. So that will also one of the NLP application. So maybe we'll discuss some few more like a topic modeling, where you can find out the topic. So in topic modeling, mostly it is a statistical modeling approach to discover the abstract topics occurs in a collection of documents. Now mostly you have a lot of documents are there. Now you want to find out okay, these documents are of what is the topic, or the, for example, same thing for text or for speech also. For example, if you have some speech, you want to transcribe those speech or convert for those speech into text, and you try to find out okay, what this what is the speech is about. For example, you have a telephone conversation, now you try to convert to text and you try to find out. So for example, I have a call to a customer is called to a bank, and he has spoken for 5 to 10 minutes in a different issues, like he has some issue or maybe relating to some loan or some of his own issue, and you can do it okay, after this conversation you can find out the topics. So that will be, I think topic modeling is quite important, because it can save you a lot of time because you need not to, somebody need not to listen, or somebody need not to go through all the text, and they can find it easily. And also mostly it will be unsupervised approach, and where you don't have any label, because when it is when you assign to the label, it will becomes like a text classification. Otherwise mostly it will be unsupervised or semi-supervised. In semi-supervised, where you can input some additional information, or you can guide some of the topics, you can assign looking into the particular words, So it has a lot of application, text mining, text classification, machine learning, or information retrieval, or recommendation engine. So that is another popular topic modeling, popular NLP application. And now, most recently, this is one of the very useful about language model. Uh, we all know that, okay, every day actually we are using knowingly or unknowingly. So what is language modeling? Or the language modeling. So it is the task of predicting the next word in a sentence, given all previous words. So I think most of the person we are using, like when we are trying to type something or try to in email we are trying to something, it will suggest next few words. So how does it works, or how does it happens? So the language models, it will capture the general aspect of input text that is almost universally useful. So maybe somebody is thinking like, okay, this is language model, but really how it works. So maybe I have added a few slides. I hope those are interesting. Okay, I'll not go into much technical, but in overview, I can give you. Excuse me. So mostly actually it is a, before that actually I want to tell you something about this bot. I'll not go the architecture explanation, but mostly this will be this bot. It is an open source NLP pre-training model developed in 2018, and bot trains a language model that takes both the previous and next tokens into account, and it uses the popular transformer architecture, which I have highlighted in the right hand side, and that is quite popular from, I think it was initially introduced in NLP, then speech, and it will be like it has into slowly it has a lot of application in other areas apart from NLP. So it will be, it uses a word pieces mostly, like you have like a playing, it will divide it into play plus ing, and the main advantage or the main key factor of this is a how it works so well. It is like that it has trained with a very large amount of data. So if you look into, okay, but pre-trained on a large corpus of on-label text, which include entire Wikipedia. So you can imagine like what will be the size of entire Wikipedia, because already I have given some statistics of how many languages available in the Wikipedia. So so, and book corpus. So it will be, so like we can call like millions of words it has used for training, and I think it is not easy for any single organization to train this because we have a limited, all have the limited resources. So that will be, it requires a lot of resources. So to build such kind of huge model, so that will be, it's one of the key, I can call key strength. And when we're talking about transformer model, okay, I'll not go to explain the details, but when we say that, okay, the attention, or when we say that, okay, the attention, we always say that, okay, attention mechanism, how it works. So this will be a simple example. So if you can see left hand side, I have written a sentence, and right hand side another sentence. It will be split into tokens, or you can call it into maybe words. Like the animal didn't cross the street because it was too wide. Now, as a human being, so this is a very simple question: is it referring to the street or the animal? So it's a simple question for us. Like if you ask any human being, okay, he may, it will be easy for him, but not for the like um, computer or the algorithms, because it needs the self attention, allows the model to look at the each word. For example, if you look into, we have highlighted here each word. So it has put attention, or it is trying to find out the like it comparing with each of the words in the other sequence, like eat with the, eat with animal, so eat with street, and it has also, you can see the, there will be different stream. So this will be the idea behind the self attention, like where you can figure it out, like how you can it will be, you can call that, okay, where to put the attention. It will be also used in machine translation with the similarly. For example, like when you see that, okay, if you give a paragraph for translate to any human being, so he will go like first you will read a one paragraph and you try to translate, and when you try to second paragraph, maybe sometimes many times he try to look back. He look back means, okay, he will try to, okay, translate into few words, again he'll look back, and again he will try to find out the next one. So this is the same mechanism we're trying to follow, the attention. And again, and when we're talking about this bot, so in this bot it uses the same attention mechanism. In bot, the attention mechanism lets each token from input sentence focus on any other token. For example, like as we have already seen, the word it attends to every other token and seems to focus on street and animal. And bot uses, and it uses 12 separate attention mechanism on each layer. So that's the mechanism of this bot. And so mostly it works using two strategy. I'll give you very overview. Like mostly it talks about two strategies. One is like mask language model and next sentence prediction. So what is the mask language model? In mask language models, now assume you randomly mask a few words in the sentence. For example, like there will be input sentence like the, and there will be some whatever means from the whole sentences. You choose some of the words. Let it be assume 15%, and you mask it. And after mask it, you try to predict those words. So that is we call it mask language model. And the second in second approach, for example, in the first you can see the, okay, the input, the mask one is not working, it's unable to mask. Actually the sentence will be like mask one is computer, the computer is not working, it's unable to start. So we mask this computer and the start, and we are trying to figure it out, okay, what this mask words 1 and 2. This will be like the first strategy, mask language model. And in the uh, second, we say, okay, next sentence prediction, where in the training process, the model receives a pair of sentences or two sentences and learn to predict the second sentence in the pair with the subsequent seconds in the original document. For example, like you can see, like which one is occur, which has the dependency, the sentences which has dependency on which sentence. For example, two sentences are the A and B. So B the actual next sentence that comes after A in the corpus, or just a random sentence. So first sentence is the computer is not working. Second sentence is it's unable to start. So if I ask, is the next sentence, is the sentence B is the next sentence? Obviously, it will be yes, we can say. Or suppose in the second example, the computer is not working. Sentence B is coffee is very tasty. So these are not related. So we can say that, okay, this is not a next sentence. So this is actually these two mechanism it used for when we see that, okay, in the before first example, when you see that, okay, what is a machine? So it will try to predict the next sentence, next word. So basically it will use this attention mechanism. And how it already I have given some hints, like this mask language model and next sentence prediction of this bot. So that will be and if you want to figure out more into the language model, definitely you can go through it. So there will be like it's a vast topics, and vast topic where people are doing a lot of research. So that is one of the application in NLP language model. And also another popular application like text summarization. In text summarization, you have a document and you want to summarize the text. So this one will be, for example, okay, without it will be like, okay, we can call sometimes the gist, like, okay, you have a or meeting minutes, like you have a meetings of 1 hour. Now you try to extract the minutes. So similarly, so there will be actually basically two approaches are there in text summarization. One is extractive summarization, and second one is abstractive text summarization. So so in extractive summarization, mostly it will produce the summaries by choosing the subset of the sentences. So like if you look into the left hand side, okay, some sentences are there. From the sentences which are available in the source document, it will try to collect some of the words or some of the content from the original document and try to create the summary in terms of extractive. And in the abstractive summarization, it will be like more we can call more better, but what it will do, it can choose any of these words. For example, like maybe some of the words maybe not exist in the source document, but these have quite good meaning. So like in human being, for example, I'll ask you to do a summary of one page, so you can add your own word during the summary. Means it's not necessarily that you will only use the words which is available in the source. So you can maybe you can introduce your more better word. So that is in the abstractive summary, and it will be like mostly in with the deep learning. It is a quite good, we can say, because if you have a lot of data, and it can produce good summaries. But the only problem with that, like many of these languages, for example, like if you go to ODI, you want to try to build an abstract summarization, where is the data? You won't get any text summarization data. So which I was explaining in the beginning, like most of the technology, they can only be work you have the data. So maybe you can get a data set in maybe in English or in German. Even I tried in the German. Even one of the very one of the paper in 2019 EMNLP, I propose like if you don't have any summarization data, how we can build a good summarization systems. So I have proposed, okay, you can do some abstract summarization systems using generating some synthetic data. And I think that will be the means, maybe that approach is the first approach to build text summarization in using synthetic data. And I think it is quite popular. And after that, many people also uh, uh, did the research, and they try to uh, produce means different research ideas based on that, because this is because it will be a similar problem with for many languages, not only for Odia or other languages, for many low resource languages, because such data sets are rarely, means it will be either they are not available, or it will be, if it is available also, the size is quite small. So that's why this generating the synthetic data, it is a good approach which can also improve the performance. That is another excuse me. And another approach of NLP is popularly like machine translation. Like in machine translation, already people are known. So like where you have some text or some speech in a source language, and you have a target language. So this is quite simple, but actually now we are talking about neural machine translation. So we are not talking about any statistical or numbers based approach or interlingual based approach, but to just to know the purpose. Okay, I have drawn the diagram. So like before this, like few years back, the translation was not means the quality was not so high, because people are they are using different approaches like interlingual based, like you have a source language, so it will be converted to some intermediate form, and from intermediate form to target language. So to reach to this particular neural translation, it took long time. And but now you can know that, okay, after this deep learning, now we have a lot of resources in terms of lot of resources, like we have a lot of, so we have GPUs are available now, we have also data set have also increased. So using the data and these resources, this deep learning models, actually we are getting very good translations. So so if anybody is interested, maybe you can go through this interlingual based or transfer based, but those are actually nowadays it is not much used. Mostly now we are using statistical or neural. If it is very less data, we are trying for statistical, else neural. And mostly in neural machine translation, you can see how it works. Means basically there will be an encoder and a decoder. So all the in input text we are trying to convert into it will be all the input text. It will put it will make you a compact representations. As you can see, like we have market like some numbers like minus 0. 0.2, 0.1. So it will have a compact representation, and you, the decoder side, it will use this to again do the translation. So this will be simple neural machine translation architecture, but with the transformer based. So this will be little bit changed, where okay, we have introduced the attention based mechanism, like where during the translation also it can look back, and we can select the sentences which will be fit or more appropriately for the next word. So here I have given a simple example. This will be from our translation model. We have submitted in WAT 2022 2020. You can see like this will be from English to Odia. So you can see like how good or bad it is. So as you can say, okay, now the translation quality is very good. What we are getting, even in 2021, even it's much better. So now, because all the data sets are available and models are there, so translation is not a, I think day by day it is improving in a very rapid way. And people are expecting that okay, some days it will be matched to the same like human translators, how they are doing. The computers also are doing and in the same way. So that will be also one popular application in machine translation. And let's see how much time I have. So now I'll talk about this is all about some of the applications. Now I'll speak about some case studies. First case study, actually I'll talk about corpus development. So corpus development, okay, in NLP many times we say this is what is means corpus. So what is corpus? Okay, if for those not known to this word, okay, I have written here corpus, or the plural is corpora. It's a collection of linguistic data, either compiled as written text or as a transcript or record speech. So whether it is a speech or it will be text, so we can call it as it's like a collection of data, you can say. And in NLP, this corpus contain the text or speech data, and it will be used, which are used for this AI or machine learning systems. And generally, when we say this corpus, okay, the big the size, the performance will be better. Means it's a normal, but it's not always, because also you need to consider the resources and other things before considering this size. So now this corpus, suppose for example, okay, anybody start the research and he want to build a corpus, because already I have seen, okay, we build out of corpus, like okay, um, Odian corp, okay, that will be English to Odia machine translation or Hindi visual genome. So a lot of corpus we develop. So how to build? So if somebody is trying to do or build a corpus in text or in the speech, so these are some of the steps which I have highlighted. So first is like you can divide it into three phases. Like one is data collection, second one is data processing, and third one is finalization and release. So the data collection phase, okay, you can first you need to consider what will be your what is the data types, whether data types is text or image or speech or video. Then okay, now you know that okay, I want to build a text corpus, or I want to build a speech corpus or image. Now next you can consider about the sources, like from where you want to collect the data. It will be through web or some social media or some book or recording. So that will be next step. Okay, once you know, okay, these will be my sources. For example, those data are available in the web. Then you can use some of the, or you can build some scraper, web scraper. You know the okay, this will be the URL. Okay, I can download it, the text or language text tags, or you can also can use some bot, or for example, like when you are working for very means low resource languages, so there will be no text data available in the internet or in any URLs. So what to do then? Okay, then okay, maybe you can use optical character with OCR. So you have some printed material is there. So those printed matter, okay, you can use OCR to extract the text contents. And if for that particular language, if your OCR also not support, then you have to think for train a OCR model for that. And actually, those are the real research. So, for example, now I will say that okay, I want to build a corpus for a whole language. Like we now the whole characters are not supported in OCR. Then what to do? Because this is no digital platform or the website, there will be no data is available, and there will be no printed records, or if some printed records are there, it is in PDF format and this OCR doesn't work. Then what to do? So these are the real challenges which uh, the research which we used to do. Even for in Odin Corp also we did the same thing. Even I can explain in some slides. And okay, now you can extract the data. So for data extraction, you can use some tools and libraries, Python or some beautiful soup. And once you collect the data, next one is the data processing. Now you start processing the data because now you have the raw data, and raw data actually there will be a lot of noise are involved. Then you can do those segmentations or some kind of alignment. And for this also you can use some of the tools like Hunaline. There's many tools are available which you can use for such kind of alignment. Like for example, if it is a machine translation, then there will be exactly one-to-one data has to be available, like English to ODI. Parallel data will be there. Like for each of the English sentence, there will be equivalent ODI sentence will be there. So, for example, now you have extracted the text from Wikipedia or some websites. So that will be in the okay. Maybe you have the website has two versions is available, English and ODI. You have extracted the data, or you have extracted the data from using the PDF like English and ODI. Now, but there will be no matching will be there. So those things you need to do some kind of segmentation and alignment. And once the data you have processed the data, then you can do the some kind of splitting of training, development, and test. And then you can apply the baseline. If it is machine translation, what will be the baseline of the performance? And you can choose some license. Like okay, most of the times we choose Creative Commons for non-commercial purpose. So anybody, it will be free for research purpose. So you can choose the appropriate license, and you can release the platform whether it is a Lindat or a Genodo. So you can choose, and the data is there. But if the data is nobody is using, then that is also new. So you can also try to promote your data. For example, okay, we share some organization set task, WMT or WAT. WAT is like workshop on Asian translation. So where so many workshop and conferences are available, so where you can promote it. So like in WTO since 2019, so we are participating means as an organizer, and every year we used to promote our data, and it will be we are trying to organize the same task. So that is the way. And if you give some feedback, because you don't know how what is the quality of your data, so once you get the feedback, you can try to improve your data on the next person. So that will be the standard procedure, I can say. So for example, some sample I have given, like when we build the ODI English corpus. So you can see that okay, we have tried to find out okay on online resources, like where we can collect the data, or some Wikipedia, or some images are there, or some parallel corpus is already available which we think we can use it. So okay, we have collected the data, and also we pre-processed, and in some cases also we have to involve some of the volunteers, like from the OCF, sorry, using OCR we have extracted the data, but still it has to go through some of volunteers to make it final, because machine cannot do it, means it's very difficult for those due to if the quality is not very good, then you have to also use human volunteers, and finally it will build the data. So yeah, so as I mentioned, so already, so you can extract the plain text, or you can do some manual processing, and sentence aligned, sentence segmentation. Sentence segmentation already I explained the paragraph segmented into sentence based on English like your full stop mark, or in Odia we called it a Purna Viram or Odia Dandas, like where you need to split into, and then the sentence alignment, because it will be, if you look into this means sources, for example, like in ODI wiki, so manual sentence alignment for ODI articles, where text in two languages are independent of each other. For example, there will be in English one line will be there for the same sentence. In Odia, that will be multiple lines will be there. And how we can match it? So because in the translation it has to be exactly it has to be matched. Each English word, English sentence and Odia sentence has meaning has to be same. It will be so those things actually you need to do it. And finally, okay, we have released it. As you can see already it is available. So this is the statistics. So this will be a typical case of a corpus. And also I'll talk about recently also we released Odian Odia tree bank. So this will be tree bank. I can say this will be a collaboration work. So like many of the participants and organizers are there, like Dr. Satyaranand Das, Kalyani Malini Sao, Saraswati Sao, and Vijalakshmi Madam. So it's a collaboration work. And why we did so. So the simple answer is actually when we long back I was preparing the Odia NLP resource catalog. I asked the organizer, "Can you give me the link of Odia tree bank? I want to include it." They said there will be no Odia tree bank available. I said it will be I think 1 year back. I think one maybe 1 year back. I said, what is means how come it is possible in the universal tree bank there will be hundred of languages are there, tree banks are there. Why Odia is not there? They said, no, it's not there. Why don't you try? So try to build your. So in the same way, even for the Odian Corp also, I asked when I tried the translation, I asked them, my supervisor, can you build a machine translation in English to Odia? He said, of course you can build, but do you have data set? I said, of course it will be there, but I didn't find any data set. Then I built it. I tried to build it. Of course, actually we have a very good collaboration, and Dr. Satyanarayana Das is there, and we have also many good collaborators are there who helped a lot to build this kind of resources. And in the same for Odia Tree Bank, but in Odia Tree Bank the challenge was there, like I was in computer science, and building a tree bank required a lot of linguistics because it's a because you need to annotate it, like you need to know the grammar very well, and also you need to know the standard universal guidelines, so universal dependency guidelines, and you need to know the expose you pose, like yeah, so it will be it is not a computer scientist. I think it will be very difficult for to build, because you need to know the grammar of your languages very well, and you need to annotate, and also you need to follow the standard. So that's why it's a collaboration effort between linguistic and computer science. So if you can see already Dr. Kalyani Malin Sahu, I think she's also chairing the session. I don't know if Madam is attending the session. So yeah, so she's from linguistic. Atul Kumar Oja, he's also linguistic, and Vijalakshmi Das, she's also linguistic, and Saraswati Zhao, she is from Institute of Mathematics. I think she's also session chair. We have invited her to work as session chairs. Yeah, so this will be like, and this is part of our internship project. So yeah, so many interns comes and they work with us, and this is the kind of output we are trying to produce, some kind of meaningful output from our research work. And yeah, so I'll not go into much details of the time constraint, but yeah, so this will be available already. I have given the link of the Odia tree bank. But this is also at the same time I want to mention that this is also quite small, because we have only build the test set, but it has to be built all the training data set, and which we are working. And yeah, so hopefully if any linguistic or anybody want to contribute, they are welcome, and we can continue. And also the last case study, I think I'll explain about this bot Odia. So in bot Odia, actually, as I have explained the bot, so we have also tried to build a bot for Odia version. So this will be like specific to Odia, because if you look into multilingual bot, it supports a lot of languages, and it has its own advantage and disadvantage. So we are trying to build a language specific bot for Odia. And so if anybody is interested, they can also go through the details of this particular paper, which already I have shared. But the idea is like that, okay, first you need to collect a lot of monolingual data, which I have given in the dataset statistics, Odian Corp or CBIT, so Oscar, Wikipedia. So, and the main challenge is that, okay, after you collecting the data, to train this, actually your memory should fit into that, which they are actually got little bit of problems, but we try to reduce the data set size, and this will be the model training and performance. And we can see that, okay, this will be around, we have got more than 90% for both bot and robot. And also we have tried in different tasks, like to measure the performance, like in the clue task, like for question answering and news article classifications. So, and it performs quite well. So we also compared with the IndicBot, and the advantage of that, okay, we have trained only with the 6% of the data set which IndicBot has used, and also we get the good performance. And still there will be scope, like we still we have not used, we could not fit into memory all the data set, because we have also limited the GPU, and which can be improved in further. But there will be a collab, all the link in the collab link, everything is there. So anybody interested, they can try it. And so at the end, I think I'll finish with discussing about the mini project. So this mini project actually explaining about, I have given a simple idea about building a ODI dialect corpus. So what is the problem? So the problem is that now this ODI text, or which we are writing in the ODI script. So how we can distinguish different dialects in the ODI script? Because if you look into, I have written like although the script is same, but ODI there are different dialects like Sambalpuri, Ganjam, Balesur, Desia. So there will be different dialects are available. For example, now if you try to put into any language identification tool, whatever you put, it will tell this is ODI. It won't tell you the dialects or anything. So now you want to build some applications or some NLP application or NLP tools and technology for this. So how you build it? So first thing is that you need to detect the language. For example, now tomorrow you want to translate, okay, my English to Desia, or English to Sambalpuri, or English to Balesuri, or any other application also. For detecting the language first, you need some data set. So that actually we are trying to build. And this will be the mini project link. So where already I have given the details, like, okay, this will be, so in the mini project there will be many dialects. So maybe we'll not go through all. We have maybe first concentrate on 4 dialects, 4 to 5 dialects. And I have given the details, like what will be the approach, like we can collect the data. For example, assume we have taken thousand sentences, and from this dialect, Ganjami, Odia, Kotaki, Desia, and Balesuri. Then, okay, we can collect. Then, after collecting the data set, we can assign some of their language ID or some tags using these are the IDs, standard IDs, which we can assign it. Then we can try to build it. But how about the classification? For the classification, already I have given the links also. So for our language identification, for language identification, already we have proposed, I think a few years back, 2 years back, actually, a this will be based on from the paper where we have built for Odia to Santali. Odia to Santali means, as you have mean that, okay, in Santali, so they are using Olchiki script, but apart from that also, Santali has been written in different script, like Odia script, Bengali, so it follows different. For example, Santali, those are in Odisha, they follow the same Odia script for Santali language. So for example, okay, so this is a Santali. So how we can detect it, Odia versus Santali? So that actually we try to build a small data set where so if somebody is interested, they can go to it. And So this is actually this this model already the code is available, so anybody can go through it. So this will be about deep supervised autoencoder for language identification, and this performed very well. Like we tried already in different tasks like fake news detection, language detection, and also in some of the sad task already we have used it, and it is very easy to run. So only you have to run a code language detection. This is the Python file, and here all the codes are available. So for example, what needs to be changed, this is very simple. So based on your language ID, for example, you have 5 classes, so you can assign the class here, and obviously you need to change for the data set. And also this one is very simple. It will try to first extract the features. So the feature extraction is basically mostly for like your character or word engram. So whatever you want, you can use it as for feature extraction. And after the feature extraction, this is the space for supervised autoencoder, where it will be create the class, and also it will use the Bayesian optimizer. For example, okay, now what will be the the hyperparameter, which how I'll know which hyperparameter will be best. So for that, okay, we have used Bayesian optimizer, where you can define a range of hyperparameters, and the model will try and search, and it will choose the best hyperparameters for the classification. So that will be the here the search space is there. Like you can define the different activation function or learning rate, and it will try, and at the finally it will give you the prediction. And if somebody is more interested, you can go through the class. So this will be the supervised class where we have defined. So this epoch default is means it is 500. So you can start, I think, using 30, it will be fine. So for example, if it is the data is less, maybe you can try 20 to 30. It will be really, it will work. And the performance also quite well of this supervised autoencoder. I think this is the first time we applied this supervised autoencoder in NLP. Otherwise, most it started with a image processing, but we thought, okay, let it try, and it is in collaboration we have done, and it was really good. And even some people have now extended into speech. So those are working in mini project. I will encourage them to try this. So, and in case you have any issue, feel free to contact me. I don't know. I think I have extended some time. Yeah, so thank you all for listening. So
a great session. It was highly informative. It was really worth listening to you. It's a great honor to have you also. Thank you very much.
yeah, so
open for questions.
Yeah, so feel free. So if you have any questions, okay, you can take few questions. And yeah. So you can maybe you can chat, you can type it, or you can ask me, or otherwise no problem. If you can in the subsequent slides also, I'll be there, so you can take some question, no problem.
If anybody want to ask any questions, you can chat or you can ask.
There is a question. Could you explain a little bit of explainability in context with the NLP? Yeah, so actually explainability in NLP, actually that is a completely different topic. Yeah, so mostly actually many things many things actually when we are talking about in NLP. So like as I mentioned also, like there are many different areas, like we want to try to, when we say that okay, these deep learning models are perform better, or this is like some kind of magic box where you can get the input and the data. So many times also we try to understand understand how it really works, and how the things, for example, we are talking about many concepts, transfer learning, starting from transfer learning to domain adaptation, many things are there. So but how those things are really work, so that will be, I think, a complete different research topic. So if you have something like specific to explainability, maybe you can ask. If I know, then I'll answer. So like as I said, like explainability, or this particularly in deep learning, actually there will be a lot more things, research is going on. For example, when you see that okay, model learns, like model learns, what exactly it learns. So that is that is also a quite interesting topic. So when you say that okay, transformer works, so exactly what it learns. And for example, when you say this zero shot working, as I have seen, for example, I didn't put any of this ODI data, but still it is able to categorize it. Or when it is learning from one language and it is trying to produce in different language. So how it works. So those are actually many research topics. So people want to try to find out. So yeah, so anything specific, maybe I'll try.
So any other queries from the participants? Sir, I think we don't have any questions.
Okay, no problem. So maybe can announce about the next session. Yeah, okay.
Yes, sir. So I would like to thank Santipriya sir for this valuable lecture on LLP and its application. You also explained in detail about the mini project, so it's gonna help the students a lot. I highly appreciate your expertise in this field, sir, especially your contribution towards building language researchers for ODIs. It's really appreciable. So definitely the session will be very useful to all the students, especially who are interested for this particular mini project, ODI dialect corpus.
Yeah, thank you.
So
our
time
next
to close.
Yeah, so next session will be at 3 p.m. Dr.
Yes, sir.
Satyaranjan Das.
The next session will be of Dr. Satyaranjan Das with the topic clustering.
Yeah, thank you. So hope to see all in the next session. Yeah, so thank you all. And thank you, Manisha. Thank you, Santana. Yeah.
Thank you so much, sir. Thank you.
Thank you so much, sir. So see you all at sharp 3 p.m. Thank you all.
Thank you.